Hello everyone, good evening. Please wait for some more time. We'll start in 5 minutes. Please be on the call.
Hi guys, we'll just wait 2 minutes and we'll just start off with today's session. Fine? Audible? Am I audible to you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Great. We'll just wait 2 minutes and we'll just start. Fine? Okay, guys, we'll just start off. Just allow me a moment. We'll just start off. Is my screen visible to you?
No, ma'am.
Not yet, ma'am.
Okay, okay, just a moment. I'm actually facing some network issue. Just a moment. Now, is it?
No, ma'am.
No, ma'am.
Now, can you see? Guys, can you see?
No, ma'am.
Yeah, ma'am, it's loading, but it is coming very slowly because we are just seeing that usually we see in when you present the screen, we can just sing, but it's blank still.
Okay. So you cannot see it, right?
No, ma'am.
No, ma'am.
Okay, okay, just a moment. Let me just stop sharing and reshare. Now,
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am, we can see.
Yes, ma'am.
okay, okay, great, great. Fine. So we'll just start off with the with last day's file only. Yeah. So we have actually done with most of it, but we are left with, I guess, this part because we need to calculate about the distance matrix comparison. This thing we need to look into. So we will be looking the different way of defining. First, we will be looking at like the different way of defining the intercluster distance of the similarity. Then we'll slowly like going ahead with that, we'll be able to understand how we have calculated this and how we have compared about this and how we have gone ahead. So we'll just go ahead with that. So the very first thing that will be showing different ways of defining the intercluster distance. Okay. My voice is audible to you and the screen is visible, right, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Great. So you can see it, right?
Yes, ma'am.
Okay. Okay. Fine. Great. So what we are going will we will be seeing the different way of defining the intercluster distance. Here, what happens? So first, we need to understand what intercluster distance is all about. Okay. So in case of hierarchical clustering, what we do, we need to know how far or similar the clusters are from each other, right? So yesterday we have seen this diagram. I guess where I have drawn it. So this one, there were two clusters and there we actually calculated the distance. So in the same form, we will be calculating it up here that that will be showing us like we need to know like how far or similar the clusters are from each other. So that is our main intention. So why we need to do it? Because we need to decide which cluster to merge next. So hopefully you remember how we are doing here. We have, in case of agglomerative, how we did it. We have taken it down, calculated the distance. Based on that, we have merged it, right? So this intercluster distance is necessary to calculate like how what actually it is because it is actually the process of knowing how far and similar the clusters are from each other because we need to decide the clusters about the clusters and need to merge them together. Okay, so there are several ways of defining them. That is, we can do it by distance. Here we have used the Euclidean distance, or we can also do the similarity check. Fine. So there are different ways that we can take into consideration. So we'll go ahead and see one by one. So the first one is single linkage. Okay. The second two that we will be taking into consideration is complete linkage. Third one, that is the average linkage. Fourth one, that is the centroid linkage. And the fifth one is words method, right? These are all of the forms that we'll be checking, right? So what actually it is? So we will be going ahead and see what are the single linkage. So based on that, we can think of like the distance between the two clusters, what it is. It is if it is the smallest distance, like generally when we are taking into consideration and want to merge two clusters together, then what we take into consideration the distance. So the distance between two clusters is the smallest distance between any single point in cluster A and also any of the single point in cluster B. Right. So how we are checking this in that form? We will be checking the distance between the two clusters and also in between the each of the single points. Suppose any of the single point in cluster A and any of the single point in cluster B. So this single linkage is also called the minimum linkage. So let us just take it with the help of an example. Minimum minimum linkage. How we will be taking it into count. So suppose we'll take a cluster point. We'll take a cluster point. Okay. So cluster A it is, and the cluster point is around A1, A2. Next, we have another cluster that is cluster B, and the point would be B1, B2. Sorry, B2. Okay, so we have taken two cluster points. Now, what we need to do, we need to take the distance, and we need to take the minimum distance. So, minimum distance, that is the distance between A1 and B1. Now, distance that we will be taking A1, B2. Now, we'll be taking distance A2, B1, and we'll take the distance A2, B2. Fine. So this is how we'll just take the distance. So how we will be taking it down. So we have taken cluster A, this is this, cluster B, this is this. Distance equals to mean dist A1, comma B1, distance A2, comma B1, distance A2, comma B2, right? So these are the values we will be taking. What is the goal? We need to take the minimum distance. So we will be taking two different data points. Let me just draw it for you. So suppose this is a cluster and this is another cluster. And here there are some data points. Okay, so we have taken cluster A point. We have taken the cluster A point as A1 and A2, and cluster B point B1, B2. We have taken it like this. Now, how we are doing? We need to get the minimum distance. So we are comparing each of the points with A1, B1, A1, B2, A2, B1, and A2, B2. All of the distance we are calculating and taking the minimum one. Okay. So this is how the single linkage is occurred. That is the reason, since we are taking into account the minimum distance, that is the reason we want to take into account with this. So distance between two clusters is the smallest distance only when between any of the single points in cluster A and in any of the single point in cluster B. Okay, so how we are checking it is by using the smallest distance. So clear, guys, this much you understood how we are taking into account the single linkage or the minimum linkage.
Yes, ma'am.
Yes, ma'am.
Okay, great. So what is the pros of it? Like if you can think of why we are doing it, why we are doing it, how we can get it. So it is used, or we can use it when it is basically good for finding like if the data or the shape of the cluster that is elongated or irregular shaped clusters. In that format, it is good to find. So here I have taken circular, like just for an example. Suppose in any case the shape is elongated or the shape is irregular anywhere, any what, in that format also, that is the plus point in this case of single leakage. So let me just go up. So here you can see in case of mean, we have discussed about minimum linkage. See, all of this clusters that has taken into account, they all are elongated. They all are elongated. This is how we are taking into account with the single linkage or the minimum linkage. Fine. So, and where it doesn't work better, it doesn't work better when it is sensitive to noise. Actually, it is very sensitive to noise. It cannot go ahead with any of the value for like any of the points that are too far. Okay, so if the values are getting too far or can cause like it doesn't get grouped up because the data points are far apart. In that point, it is not easy to work with single linkage, and single linkage doesn't work good also. Fine. So this is this part. Next, we'll just move ahead with complete linkage. So what is it? It is the maximum linkage. What it is the maximum linkage. So how we are defining maximum linkage? It is the distance between two clusters, uh, like the intercluster distance that we can think of. So it is the distance between two clusters. Here we, in place of the smaller one, like the minimum distance, we are taking the largest distance, like the large distance between any single point in any of the cluster A and a single point in cluster B that we are taking into account in case of complete linkage. Other thing is same. Here we are taking into account the max value. Okay, in case of complete linkage. Here in place of mean, we are taking max value. Clear, guys? Understood what is mean linkage, what is max linkage, or max linkage is called the complete linkage. Understood, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So here it is sensitive, like based on this, if you have to compare this. Complete linkage is less sensitive to noise, but this one, the single linkage is very prone to the sensitivity to noise. Okay, so this complete linkage doesn't work better or doesn't work efficiently in case of like large clusters. You can think of when we get large clusters, it doesn't work good, but it works good in case of small clusters. Okay, so next one is average linkage. So average linkage, what it is, here in base of that, we want to get this intra cluster distance based on the fact that we have got this cluster distance between all points of cluster A and all points of cluster B. Okay, between in case of single and in case of complete, what we have taken, we have calculated the mean value and the max value based on any of the 2 points of cluster A, any one point of cluster A and any one point of cluster B. So in average linkage, we calculate the average distance between all the points in the cluster A and all of the points of cluster B. Okay, so this is the major difference. So this is average linkage. So how we calculate it? We take the distance, that is the intra-cluster distance, that is the distance that we will be taking it, and will be doing the all pairwise distance. We will be taking it and will be just doing the average. Okay, just doing the average on based on the all data points of cluster A and all data points of cluster B. Okay, so this approach is more balanced. Like you can get a balanced approach between, like, if you can compare about the single and the complete one. So this average linkage is more balanced. Like here, in case of single and in case of complete, we are choosing the data points. So there we might face error. Like if we choose any other data points, it might create other problems. Like it might create the distance might be something else. So here, in case of distance average, there is no point of choosing. We are including all of the data altogether and doing the average. Clear, guys? Understood? Guys,
Yes, ma'am.
understood?
Yes, ma'am. Yes, ma'am.
Yes,
Everyone?
yes, ma'am.
Okay, fine. Next, we'll just go ahead with centroid linkage. So centroid linkage, what it is? It is, as usual, the distance between the cluster. That is the intra-cluster distance. It is the distance between the centroids. It is the distance between their centroids. Okay, so what we are taking, how we are taking it to count? We are finding the centroid of cluster A. So what is the centroid? That is actually the average of all its data points. Okay, how we are getting the centroid? Centroid is the average of all of its data points. So that value, that is actually the centroid, that is the center. So that is the centroid for cluster A. Similarly, average of all its points for cluster B, we are getting the centroid for B. So now in distance, the distance between centroid A and centroid B. Understood?
Yes, ma'am.
Yes, ma'am.
So, what centroid linkage is? Centroid is the distance between the centroid of A and the centroid of B. Okay, so it is, I guess, anyone who is able to average linkage, they will be able to get the average. So, centroid, getting into centroid is pretty easy because here for each of the cluster, we need to get the doing the average And in case of average, we take all of the points of all of the data points and doing the average. That is the specific difference that we can take into account. And in case of the centroid linkage, it actually what it does, it captures the overall positions of the clusters. So here in details, what we can get the overall positions of the clusters. So there might be situations since we got some of the useful data, there might be some of the fonts also we can take into account where it may not handle the non-spherical shape of the clusters. So there are spherical shape, elongated shape, right? So it might be condition that it may not handle the non-spherical shape of the clusters. Like any clusters that have a non-spherical shape, that in that form the centroid might not work properly. Okay. And next, the last one is words method. So we have taken into account the words method. So what it is, it tries to minimize. What it tries to minimize? It tries to minimize the variance. What is variance? The sum squared difference, SSE. So it tries to minimize the total SSE value within the clusters when we are actually merging them. Okay, so what it does, what is the work of words method? It is the minimum variance method. We can call it as minimum variance method. So it is this we call as the minimum variance method. So it actually tries to minimize the overall variance, whatever be the overall variance, that is the SSE. It tries to minimize that within the clusters. So why it is doing that? So that it can produce a balanced and compact clusters. Okay, so that the clusters that we are getting, that should be balanced and also compact. Okay, this is, I guess, in all of this word method performs the best, because we in this form, after we have like it is actually trying to give us that kind of clusters that is well balanced. Okay, and also it compact the clusters also, so that we can get it in a form that we can easily able to access that. Okay, so how we are doing it? First, we are choosing the pair of the clusters that we want to merge. Okay, and we produce the smallest increase in the total within the cluster variance. Okay, fine. So that is the exact way what we are taking into account. We are taking into account of two of the values, like two of the clusters, the like the pair of clusters who we want that to be merged. Take into account with that, decrease the variance in the form, and we just take into account with that very form. So this is the words method. So clear, guys, understood?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So, in any of the
Yes,
form,
ma'am.
if you want to go ahead and put this linkage in any of your code, try and use this word methods, because this work very good. It actually minimizes the variance, okay, and it gets the clusters that we will be getting is balanced and the compact one. Okay, so this is the major thing. And in certain case, if you can, if you want to go ahead with, so just wanted to tell you, like if you have a very noisy or messy data, then I should tell that you avoid the single linkage, because they are very sensitive to the noise. Okay, and any of the general perspective you want to go, you can use this average linkage. That works good. Fine, and this is the form how they are taking into account. So see, this is first forming separately, two are getting close. Now three have taken into place. Now taking this clusters and eventually forming. They are actually calculating the minimum value, like the distance being the minimum. Here, what they are calculating, the maximum value they are calculating. And average, they are taking all of the points, averaging it down and forming the cluster. And what's, see, this, based on all of this three, all of this four, you can see this one, how it is more compact. Like it is getting the, like the space is like it is getting into in a more compact zone, and it is more balanced than any one of it, right? So this is actually the distance matrix comparison that we have discussed. All of it we discussed. And can anyone of you let me know yesterday till what portion we have covered, in case of like, I guess we are left with the mean shift, right?
We
DB
did
scan we
until
have
DB
already
scan, ma'am.
done. Yeah, yeah. Okay, okay, great. Let me just open the collab. Just a moment. Just a moment. Let me just open the collab, and accordingly we'll just go. So this is the one. So we have gone ahead with TB scan, right? This much we have taken into account, right?
Yes, ma'am.
Okay. So today we'll go and see about mean shift clustering. So anyone having any idea about mean shift? How we are going ahead with mean shift? What is the necessity of it? Necessity of it actually?
No, ma'am.
Okay. Okay, great. Let us go ahead with mean shift clustering. So as discussed, it is a supervised machine learning, and here also the same thing we are doing. It is a part of clustering only. So we are grouping the data points into specific clusters. Okay, so here also, unlike k-means, we don't have to go ahead and specify the number of the clusters that we want to go ahead. In mean shift, automatically what it does, it automatically finds the clusters based on where data points are dense. Okay, so this DB scan was also density based. This mean shift is also density based. Okay, so what it does, mean shift automatically finds the clusters that are there that is needed to be formed based on what it forms, based on where the data points are dense, or we can say it dense in the sense where the data points are more accumulated or more crowded. Okay, so what it takes, it finds what is the actual work of it to find the density level or the peak of the density where the data points tends to form a group being into a gathering. Okay, so this is actually what mean shift is. So you can think of an idea or how we can work it through. We can discuss it in a form like, uh, we can think it of how we can work with this mean shift. So first we need to take a bandwidth like around each of the data, like a circle or sphere that looks that actually give us the nearby point view. So we need to place a window, like we can call it a bandwidth. Okay, so around each data point, we put a window or we put a bandwidth. So let me just write it so that it stays in place. Yeah. So mean shift, point two, step by step. So how we are doing it? First, we need to place a window or a bandwidth around each data point. Around each data point, what actually we are doing? A circle or a sphere. We need to put it on each of the data point. Fine. So Place window. First, we need to place a place window around each data point. Next, what we are doing? Next, we want to compute the mean or the average of the all of the data. Calculate mean. We need to calculate mean of all data points. Okay. So what we are doing, we are calculating the average value of all of the points inside that very window. Okay. So now what we are doing, we need to move the window towards the mean. Like we need to give the direction to the highest pointed density. Okay. So we need to move the window towards the mean. Fine. So again, we need to repeat the step in a form until it converges. Okay, until it converges. We need to keep moving. Okay, we need to keep moving until the window doesn't move anymore. There comes a point when the window is not moving anymore. It is intact. So this is how we are going ahead and converging. And once we get into any specific position that the data points are converged at that very peak and the window is not moving, we call it a like we call it a clusters. And again, it is done for a single cluster. Again, the for the rest of the data that is not into that cluster, we again use that window, then again we calculate the mean and we move the window towards that mean, right? To get it through. Understood how we are doing it?
Yes, ma'am.
Okay, got it. So, what this bandwidth is, or what this window is, if you want to think, it is actually the you can think it of like you are putting it in a form that where we are taking into count one by one of the point based on the density of the points. Okay, so what actually the radius of this window says, like how long this window is, if you can see it, if the window is bigger, it will say like the few clusters will be there. Okay. And if this window is smaller, then you can say there will be more clusters. As you can understand, if the window is short or small, then less number of data points can adjust, right? And if the window is big, more number of data points can adjust, right? And we are doing the same. If it is adjusting more amount of data, that is more types of like more data is getting engrossed into a single cluster, you can say it like that. Then you can say in the whole form or in the whole data set, there would be limited number of clusters. But if this the radius of this window is shorter, then less number of data points will include, then more number of clusters we can take into count. Understood, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Understood.
Okay, we'll just move ahead and see the form how we have gone ahead with this mean shift clustering. Fine. So first, as usual, we have imported the libraries, taken lumpy, then matplotlib to plot it down. Then we have imported the mean shift from sklearn because without we want to implement mean shift and Python do give us the library mean shift library like clear access. That's why we are it down. So now we are defining a 2D set, 2D two-dimensional set of NumPy array that we have like initialized. Actually, we have created and initialized in the variable x. Okay, so we will go ahead and will create the mean shift model. Here you can see the mean shift model. We have created it down. So we have taken the bandwidth equals to 4. The window I was talking about, that is only called as a bandwidth. Okay, so that is the radius of the window. Bandwidth, what it is? It is the radius of the window that looks for the nearby point. Okay, so if the points are within is like 4 units for each, then we are considering the neighborhood will converge on the same peak. Fine. So this is the reason we have taken into like the bandwidth as 4. Now we have to fit it. We have fitted it down like dot fit. We have fitted it down. Now we had to get the cluster labels. What are the labels? Labels will contain in the cluster index for each of the data point that we to take into consideration after fitting has been done. Okay, so we'll be taking into suppose if we get the point as suppose 0, 1, 2, because we have this here 0, 1, 2. So we'll take into count as cluster 0. What value we will be putting in into the like what name we will be putting it, what label we want to put it. So that's here we will be putting the labels on. So for that, suppose one cluster is marked as cluster 0, another will be marked as cluster 1. Just for an example, I'm saying, fine. So now we need to get the cluster centers, right? So for that, we have used it like that because these are the coordinates or the peaks, right? Where are the peaks we will be getting? There only the clusters will be forming. So that's why we'll need to get the cluster centers. Okay, so we got the cluster centers. Now we need to just visualize it and plot it down. In the similar form, we created the scatter plot. We have given that title, X label, Y label, and show. So see, this is how actually it is looking, and this are the cluster centers. These are the centroids. Okay, understood? Guys, understood?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so we'll go ahead with a priori algorithm. Okay, so it is a quite famous algorithm. I guess most of you have, I guess, know about it. You know about it, a priori algorithm,
No, ma'am.
guys?
Yes, ma'am.
No, ma'am.
Okay, 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 great. Any one of you told about, yeah, told that yes, right? So you can try to explain. Who knows it, try and explain. Some of you told, right? Yes. Okay, fine, leave it. So we'll just discuss because most of you don't know. So we'll just go from it in a bit scratch from scratch. A priori algorithm. So what it is, a priori algorithm is it is a form of association rule learning. So hopefully you have seen, must be remembering, we have clustered this, like we have actually grouped the unsupervised learning into different models. The number one was clustering model. We learned all of it. Next, we have gone ahead with association rule clustering models, anomaly detection, and the dimensionality reduction. Right. So we'll just check it for this one association rule perspective. We'll check and eventually we'll go. So a priori actually comes under association rule learning. So it what it tries and do, it helps to find patterns or rules actually in large data sets. Suppose you are giving a data set to the model, like unsupervised, as you know, the data are not labeled. So in that form, what is the task of the model? To find pattern or rules or the hidden trends inside the given data, right? So in that form, it is we are using a priori algorithm. It helps to find the patterns or rules in case of large data sets. Okay, especially you can think it of any of the data set may be related to Market research, you can think of market research analysis or any of them. So there you try, because there we don't give any like data specifically to the model, like any kind of label data we are not giving to the model. We are directly giving it to a form. Am I not audible, guys? I'm audible, right?
Yes, ma'am. Audible.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am, you
great.
Yes,
are.
ma'am.
Okay, fine, great. As I was saying, like we try and get the hidden patterns out. So this is how so we can generally, we have generally think of, we have already known, like suppose anyone who is getting to going to a market or maybe a grocery mall, there, there if a person buys milk products, there is a definite tendency of the of the person to buy any of the like bread maybe with it, or if a person is buying bread, there is a tendency that the buyer tries and buys the butter along with that, right? So this is the tendency that the person actually checks. Okay, that the person actually checks. So here the model, if the model is given with the data, so we there is a chance that the person will go ahead. If the person is going and buying any of the bread, there is a chance that the person will try and go ahead and buy butter. So this is how, even in case of any grocery mart or any grocery mall, you can say the items that are there, that they are trying to place the items in a order that if you are going and getting for milk. Okay, so there is a tendency that you will be going and buying butter. So you see that milk and butter sometimes they keep side by side, right? And they try to put in the this butter and butter and milk this in the last section of their mall, so that the customer has to go from the entrance to the last, and in between the person can see the other products. If there is any, there is a probability if the person will see any of the product in between, they might think that I need that product. The person or the customer will buy that along with that milk and butter, right? So this is the strategy how this like the how the clients or the how the stakeholders, all the builders in a mall, how they are figuring out where to keep the products. Actually, they are understanding and analyzing the behavior of the customer. Based on that, they are putting the stuff in that form so that they can go ahead and try and end up buying more products than they actually want. Okay, understood what I tried to mention?
Yes,
Yeah,
ma'am.
ma'am.
Yes,
Yes, ma'am.
ma'am.
Okay, so here, okay, great. So it is a association rule learning. So here we are trying to, our main intention is to find the relationship between the items. Okay, our main intention is to is to actually understand or inculcate the relationship between the items that are present. Okay, so as I given you the idea about milk and bread usually brought together, so this is the form. Here we got a relationship between milk and bread. How the things are being brought, we got a comparison up. So this is how we are taking into count. Okay, so we'll see step by step how we are getting into a priori. So suppose you have a data set, okay, where you have the transaction ID and you have what you have, just a moment, you have suppose the items that has been brought. Okay, item that has been brought. So what you do, you just go ahead and collect this transactional data first. So the first part is to go ahead and collect the transactional data. Now, the second step is what? You need to set the minimum support and the confidence. What is support? Support means how frequently does the item appear in the transaction? Okay. How frequently does that item appear in the transaction? Suppose, let me just give you an example. Without that, I don't think things would be better clear, because example is the very first way where you can make the things clear, or I can just give it in Excel. That would be more helpful. So first we will be in the collecting data. First is collecting the transaction data. So first is collecting this transaction data. Now what we are doing, we are taking the first one, what we are taking, transaction ID, and then what it is, items brought together. Items brought together. Okay. So how we are doing? Suppose we are putting 1, 2, 3, 4, 5. So let me just drag it. Okay, 1, 2, 3, 4, 5. Okay, will you do the okay autofill? We are not getting what? Just a moment. Autofill option is not coming. So we have taken the transaction ID. Now we'll take, suppose, bread and butter. Next, we can take it as, you know about that concept, like beard and diaper. So we'll try and include that here. Bread, comma. Here, suppose the person didn't brought butter, type diaper, beer, eggs. Okay. Next, the same thing. Maybe the person has brought milk, diaper. Next, suppose the person has brought bread, milk. Next, suppose this person brought bread, milk. Okay. So this is how we created the data. We collected this data, suppose. Now we need to set the minimum support and the confidence. So what minimum support, like what actually the support is? Support tells how frequently does the item appear in the transaction. Like suppose here you say how many times bread has come up. One, two, three, four. Among five column, four times it has appeared. So it is around, suppose, 80% we are getting as a support. And what is the confidence? How often does the rule holds true? Like if I am saying, we'll be discussing that how frequent the rule holds true. That is, we have told, like if anyone buying bread, along with that, the person tries to buy butter. So we will analyze this and see if any, if like how many times we getting through, like a person buying bread and butter together. So that is the confidence. Understood this much? Understood?
Yes, ma'am.
Yes, ma'am.
O-
Yes,
Okay,
ma'am.
Yeah,
great.
ma'am.
So next step, what it is, we need to find the frequent items set together. Which items are actually, irrespective of the rule, which items are actually brought together, that we are taking into consideration. Okay, so if suppose bread appears four times, right, out of five, so we got the support value as 80%. Okay, so suppose we and in case of what it called confidence, what we call it, suppose beard and diaper, this thing, this elements are brought together. So this is actually the rule. So that is the confidence. Okay, so now I need to check in through. like how many times they are actually often brought together. We need to like calculate the average amount. Suppose here you can say beer diaper one time, beer diaper two times, and beer diaper one time, beer with diaper, I guess two times. Two times, okay, it is beer. Okay, so we are getting it for three times. Okay, so what it is out of five times, we are getting three times this rule. That is, people who is buying diaper at the same time trying and buying beer as well. So the confidence we are taking into count, that is frequency, that is we are taking into count for this as suppose 60%. Okay, so now we need to go ahead and generate the association rule, like from the frequently item, like the frequently bought item set. We need to create like this is the rule one, that is the confidence we are buying, like we are telling, that is beard and diaper are brought together. This is the first rule. The second rule, maybe the bread and butter are brought together. Okay, now what we'll be doing, we will be checking the confidence of the rule, like how often they are been doing. Okay, so for the confidence for A to B, we will take the support for A union B, how much it is doing by support A, that is the form. Did you people understood what I told by now? Whatever I told by now, did you understood or should I write it down? That would be more convenient for you.
Yes, ma'am.
Yeah, ma'am.
Understood, right?
Yeah, ma'am. Yeah.
Yeah, ma'am,
Okay,
understood,
fine.
but it was a bit complicated.
Yeah, because here we are taking into count. That's why I asked, should I write? Is it understandable to you or should I write? Just let me just write. That
Yeah,
would be
ma'am, can you
easier for
please
you to
write it?
understand. Yeah,
Yeah, ma'am, write it
that
we,
is
so
the
we
reason
can
I.
we can read it.
Okay, fine, great. So as I told, the first step is to collect the transaction data. Fine, we collected the transaction data. Second stage, what it is? Let me just. Second stage, what we are doing, we are setting the minimum support and the confidence. Third one, like what it is, what we are doing, we are setting a minimum. Like support, if it is 60%, we are doing like it is like the item must appear in that very chart, like in this chart, for at least 60% of the transaction. Okay, so we are setting the minimum support and confidence. Next, what we are doing, we are finding the frequent items set. Okay, just a minute. Find frequent item set we are doing, like bread and butter are brought together, and for how much support it is, like what is the frequency that we are checking, and based on that trying and converting into a percentage, so that it is easier for us to understand. So we are trying and find the frequency of the items that has been brought in a set. Okay, and next what we are doing, we are generating association rule. Generating association rule. Next, what we are doing, we need to check the confidence of rules. Like what is the rules that we are actually doing, that we need to check. Okay, so how we are doing it, we need to do confidence A to B, like it is not minus, okay? A to B, I am trying to say. We are doing, and how we are doing using support, because we have calculated the support, that is the frequency. Support of A union B, A union B we are doing by support A. Okay, so we are doing this. So support for suppose bread and butter. Bread and butter, how much we got? We got 2, right? 2 out of 5. So 2 by 5, that is, sorry. So, sorry, 2 got or 3 got? Just a minute. So suppose bread and diaper and beard, we are checking 1, 2, 3. 3 times it we have got. And bread and butter, we have got around 1 time only, right? So how many times we have take into count with the support? So bread union butter. So it is there in bread separately 1 time, 2 time, 3 time, 4 time. But butter we have got only 1 time. So we will be taking into count 2 by 5. That is bread union butter 2 by 5 we will be taking. So 40% we got. And in support of bread, how many times? 1, 2, 3, 4. So 4 times we will be taking into count. So that's why like 2 by 5, that is 40%, divided by 80%. 4 by 5 gives us 80%. So 40 by 80, that is 50%. So this is how we are checking for the confidence of rules. Okay. So this is actually how we are doing it. Understood now? Clear? Guys, clear?
Yes, ma'am.
Okay, great.
Clear.
So we'll just see how we have done the formatting or how we have done the application in code. So first, we have what we have done. We have gone ahead and taken we have from ML pattern, we have imported a priori and association rule we have taken into account. We need to generate them, generate the values. That's why we would be needing this. And we have taken into account pandas. So now we have defined the data set. That is the first stage that we have taken into account. The first stage that we have taken into account, that is collection of transaction data. So that has been done. Okay. So now we have just converted it into a data frame. We have converted it into a data frame. So now we are applying the a priori algorithm. So what is happening up here? We are trying and going ahead and forming this a priori format. So see, here we are taking df, that is the data frame, that is the value we need to take first. Next, this mean support, how we will be taking that, because here the second step, set mean support and confidence. We need to set a value. So that's why we are setting it to 0.5. Okay, so we are taking at least 60% of the transaction. Okay, understood what I told?
Yes, ma'am.
Yes, ma'am.
Okay.
Understood.
Yes,
Then
ma'am. Yes,
use
ma'am.
column names true. What we are doing, we get the actual items. We get the actual items name. In this, like we just want the actual items name that we have taken into account. If we are getting 0, 1, 0, 1, that in that form we won't be able to understand. So I want this key values. This key I actually want. This is a dictionary, right? So we want this key values. So that's why I have used this as column, like use column names. Then we have gone ahead. We need to generate the association rule. So we have generated the association rule. We have taken the threshold like this, and we have taken the matrix, that is the confidence. So this matrix on which, like how reliable the rules that we are making, for checking that we need to go ahead for this confidence. Okay. So this we are actually doing. Now we are displaying the items and the rules. So for item bread, we got the support around 80%. For butter, we got the support as 60%. And this is the frequency we have got, like the frequent items that we are got into first single way we have get the support. Next, along with like bread butter bought together. 60% of the people try and brought bread and butter together. Milk and bread together. 60%. Diaper and milk 80%. Like diaper and milk 80%. Like the 80% of the people try and buy diaper and milk together. Now, like we are going from single, then going to the double, then going to the triple form. Understood how we are just changing it over? Now we are creating this association rule, like how we are getting this association rule, like butter and bread, what is the support, what is the consent support, like all of this data, we are just printing it out so that we get all of the data similar. Like we get in through and try to work with this in a form that it is become more easier to use. Understood, guys?
Yes, ma'am.
Are
Yeah,
you
ma'am.
facing
Yeah, ma'am.
any issue in understanding? Because it is bit difficult to let you understand here, right? Because here we are calculating all of the states and writing all of the steps. It is a bit difficult. That's why I have printed it down so that you can just see what is the support for each of the section, how we are going for while we are taking into consideration of the association rule. Like when we are taking bread and butter together, what is the support we are getting? Like the how frequently, how much people frequently bought that together. So understood, right?
Yes, ma'am.
Okay, great. So everyone understood. I am asking everyone.
Yes, ma'am.
Any
Yes,
issues
Yes,
you
ma'am.
are
ma'am.
having?
Yes, ma'am.
Okay,
No, ma'am. It's
great.
clear.
Yes, ma'am.
Fine, great. Okay. Since you are not responding, I am like unable to understand whether you understood because this topic is a bit tricky. That's why I just asked you multiple of times. Did you understood? Did you understood? Fine. So we'll go ahead with this LCAT algorithm. So LCAT, what it is? It is equivalent class clustering and bottom-up lattice traversal. Okay. So it is actually a form of like association rule mining, like a priori. So we use where there we have and confidence. And here, what we are doing, we use like what we are trying and use. We are used it to find the frequent item set in the transactional data. So in the same format, we are trying and using it. And what we are doing here, we are getting the horizontal format and also the vertical format. The similar way, LCAT algorithm, what we are doing, let me write it down. Sorry, the name is. So first, what we are doing? So first, we are converting the data to a vertical format because we get here we are actually trying and using the horizontal data and the vertical data. So horizontal data, like what we are trying and we are trying to get the frequent items. What we are want to intersect the transaction. Actually, we want to intersect the transaction list of items to see the combination appears. So in Excel, we have got around this like horizontal and vertical forms. So if you are keeping it in a form like here in the columns also the data are putting, in rows also data are putting, where suppose all of the values are putting here around diaper and diaper you got the value similar. So you just correct it. So this is the form for this person and this person. This item is brought together, right? So this is how you actually try to use it. So we try to intersect the transactional list. What is the transactional list we are taking of the items? We are trying to intersect it. So that's why this is the form we are trying and using it. Okay. So this is the form we are using it. So we got ahead with getting first, we get to convert the data to a vertical form. Now we need to get the frequent item brought together. Now we need to generate the item two, second item that has brought like frequently brought together, that like we are just ranking it down. Okay. So first item that has brought together, we have ranked it. Second item that we have brought together, we ranked it. And third item we brought it together, we ranked it in a set actually, in a set. So then we are going ahead and generating the association rule that is like as it is in case of a priori, in case of eclat also, we are doing the same. Okay, so now we are just going ahead and seeing how we are doing it. The similar format we did it. We have defined the data set. We have, sorry, eclat it is. Yeah, actually it is. So we have gone ahead and taken it down uh, for the eclat. Now we have just taken it down for like the data frame. For data frame, we have converted it down, and we have taken for like we actually use the FP growth as a substitute of eclat over here because both of this like because mclat MX, MLX tend dot frequency pattern. This does have a count for FP growth. So the one for ECLAT I was not having, and in this I was facing issue here to just download it down. Like using PEEP also, I was unable to do it. There might be some issue that I need to check for because FP growth and ECLAT is quite same. So we have just gone ahead and substitute EP growth in irrespective of ECLAT. So that's why I have written it down so that we can try and use that. We have used that and we have displayed it. So here you can see the support and the item that have brought together, and this actually we have tried to put it down like what frequently bought items and in what format we want to buy it, that has been came into place. Okay, understood? Guys, understood?
Yeah.
Yes,
Yes,
ma'am.
ma'am.
Yeah,
Means,
ma'am.
ma'am,
Okay,
Yes, ma'am.
so the
Yes,
Yes,
similar
ma'am.
ma'am.
thing I did. Yeah, tell.
ma'am, actually, just I was having that doubt that the way you explain in the Excel, the way in that same way, we just need to write the code and do the in same way, right?
Right, exactly the same way itself. Like here, the Excel, I just uh, like make you understand the details, like the collecting the transaction data, because here the data need to be same. Like there need to be some of the data. Like at least if I am putting bread over here in the second person, second I they also there must be bread because here we have taken only five data, but when we are taking into count about the mall data or any of the data we are taking into count, there we are not getting all like for five people, maybe this five people brought different items, right? So when we are taking into count long data, there we will be getting all of this. So just for make you understand, I just given you this. And here also the steps that I have given you, this is the form only we need to do it. Okay.
Okay, ma'am, but can you just show the collab file once?
Yeah, sure.
Ma'am, here the metrics, how you have given 11011, is it same? Do we have to keep it same for everything or it will change accordingly?
See, just a minute. Let me just go up. Just a moment. Okay, so what actually, like what actually here we did? So we have taken this data frames. Like we have taken this, like here the data set I have taken same. So what actually we did? We have created a dictionary. These are the keys and 11011. Why we have brought like kept it? So one, what it signifies? One, it has like item brought together, zero item not brought together. So it is giving true value or false value. Okay, this is the way we are putting it. So this is rows. What this rows are? These are the transactions. These are actually the transactions that we are taking into count. You didn't understand? Hello?
Yes, ma'am, understood.
This what one signifies. One signifies that the item is brought together. Like bread is trying and brought together. together. Like here, we have taken into count this, right? Like, let me just try and go ahead and explain you in more details. Suppose we have got and brought data like this. Okay. So first is bread butter. Suppose we have taken, like, let me just make it more easy. Let me take it for three. Suppose we have brought bread, beer, and diaper. So let me just omit egg so that it becomes easier for you to understand. Next, suppose we have gone ahead with milk, diaper, and beer. Okay, let me just take three fields so that it becomes easier for you to understand. Next, fourth one, bread, milk, diaper. Let me just omit this. And bread, milk, diaper. Let me just omit this one. Fine. So this has been done. Now what we are actually doing, we are defining the minimum support and maximum. So minimum support, let me check for minimum support. That we are taking it around 60%. Sorry, 60% we are taking. Okay. Next, what we are doing, minimum confidence, that we are taking suppose 80%. Okay. So this is done. So now all list we will be taking, all of the single waste item we will be taking. So for suppose bread, for what point we have got bread? For one, transaction ID 1, for transaction ID 2, for transaction ID 4, for transaction ID 5, I got 1. Like I have got bread, right? 1, 2, 3, 4. Understood?
Yeah, ma'am.
Yes,
Yes, ma'am.
ma'am.
So that's
Yes,
why the
ma'am.
support will be 4. And how we are calculating support percentage? That is 4 by 5. 4 by 5 we are getting 0.8, right? So 80% we are calculating, that is the support percentage. So similarly for all we will be doing it. For every one of it we will be doing it. For butter we will be doing, for diaper we will be doing. Okay, so this is for single. What are the products? Bread, butter, diaper, and beer and milk. 5 products are there, right? So for all 5 products we will be calculating separately the support and the support percentage. Okay, now we'll check, like, if milk and butter, or milk and bread and butter is brought together, where I can see that bread and butter together. So only one. So will bread and butter together, second stage. So what is the support? 1. So it is 1 by 5. Got it? Got it?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Just a minute. So 1 by 5, it is 0.2. Let me just write it, else it will take into date. Okay. So for second product, second generation, we are pairing up. We are pairing up each of the products. Next, what we are doing in case of generating items, like we are trying and generating three items, like triplets we are taking this time. Okay. So triplets we are taking this time. We are taking, suppose, this one, bread, diaper, this, how much it is taking. So if anyone we are getting no, we are getting not. So for each of this, we for triplets we will be checking. Okay. Then we will generate the association rule, and then we will get the final rule uh, that will pass, because that for that the confidence level will be more. So I have given you the form, like how we are calculating the confidence. So we'll check on that. Okay, understood? Now it is clear.
Yes, ma'am.
Okay, and
Yeah, ma'am.
1 and 0 that we are taking, like, this item is brought together. Suppose there might be any of the items. Suppose if I write egg over here, So this is not brought together in the transaction that I am doing. So there, for that very transaction, I will put zero. Understood?
Yes, ma'am.
Okay. So we'll just move ahead. Just a moment, please. Just allow me to have some water. Just a moment. So this is how we are doing for this association rules. Now we'll just check for dimensionality reduction. So here is the forms we have taken into account like PCA. I guess most of you know about PCA, right? So can anyone tell what PCA is? Why we are using it? Guys?
Ma'am, it's unsupervised compression
Yeah. So
of
can you
data.
just elaborate? Can you just elaborate?
Ma'am, it's actually used
Ma'am, the
for
data is
feature
been
selection.
reduced in unsupervised way dimensionally.
Yeah, actually we are doing this. And someone else was also saying, please tell.
Yeah, I was saying it is using in reducing the features of the model, and we
Actually,
only keep those features which are important and reduce the noise.
exactly. Yeah, exactly. We are doing it. So it is principal component analysis. What we are doing, it is a technique to reduce the number of the features in the columns. Like for features are the columns in the data set. But what is our main intention? We want to keep the most important information in the data set intact. Okay, so why we are using PCA? Because it is very simple version of to use it. It is like because it makes our data very simplified in broader sense. We can think it of like that because it helps to simplify the data. Okay, so it makes the data for easier viewing perspective, and there are some conditions where it removes noise or and the redundant data that we get. It also helps to remove those. Fine. So actually what we are doing when we are having a data set that have too many numbers of columns, and it makes us into a form that it is harder for us to analyze the visualization. In that format we try and use this PCA. So PCA, the features, what we are actually keeping, features that are correlated, that is related, like which can mean the columns, like which actually means something to the data. We keep that, okay, and rest of the data that doesn't mean anything, we just remove that. So PCA actually helps to reduce dimension, that is, reduce the number of features, keeping the important information and also remove the some of the unimportant information and keeping only the important data in the track. Fine, clear. So we'll just do a bit hurry and we'll just speed the code up here. So here we have just taken down, imported the libraries, gone ahead with loading the, we have taken the iris data set, but because this data set is very well known to each one of you, everyone knows this data. So now we have taken into account about iris data. We have taken the we have segregated it with X. We have taken the data Y. We have given the labels, that is the target. Now we have taken into consideration the standardization because we need to check for the standardization. Like if our data is scaled or standardized, so we need to check it for that. Then we are applying PCA. So what we are doing here, we are trying to reduce the data to two principal components. What in case of iris data, you have four components. Now what we are taking it up, we are just going ahead and putting it down to two principal components. Okay. So now after that, what we are doing, we are actually uh, after we are doing applying after we have applied the PCA, we have created the data frame for converting it down. So for conversion purpose, we have taken it down to data frame. So we have used that fit transform. We have used like fit transform here. We have taken created the data frame for plotting. Then we have just visualized the result. What actually is the result? Like we have given the colors, what is the species, how we want to look at like. So this is the format we have taken it down. So this is how our data look after we have done the PCA. So the elbow method yesterday only we have taken into account. We have seen in details about elbow method. And next it is TSNE. This is a technique where we are trying to visualize the high dimensionally data. Where we are trying and use the why we are using this because we want to visualize the high dimensionality data, maybe the 2D data or maybe 3D data, so that we want to visualize. That's why we are using it. So we are trying to get into this form. So here what it is like dimensional data, what it means like the data with many features or many columns. uh, I have that kind of data, I want to visualize it, so that's why I use TSNE. Okay, understood?
Yes, ma'am.
Yes, ma'am.
Everyone
Yes,
understood
ma'am.
everything? Okay,
Yes,
great.
ma'am.
Yes.
So we have
Yes,
just
Yeah.
ma'am.
gone ahead, imported libraries, loaded the IRIS data set, standardization that we actually do, applied the TSNE, this form we have used. Now convert, like we need to convert it because we need to get the two columns X and Y separately. That's why. So dimensionality one, dimensionality two, we have taken into account, now plotted the result. So this is how we got the result. Fine. So we'll just for the last we will just check what is the main purpose. Like try and get the difference out of it. So what is the main purpose of PCA? It reduces the dimensions by keeping most of the data or the important data intact. And what in case of TSNE, we with reduced dimension for visualization. It
Yeah.
preserves the local relationship.
Yeah.
What? Anyone is saying anything? Okay, fine. So when we want to reduce the dimension for machine learning model, we use PCA, but TSNE is not used. When we want to visualize the high dimensional data, we use TSNE. So if the data has like no non-linear representation or relationship, if you can think it of like that, we use TSNE because anything like if we have like non-linear representation, we can't use PCA, right? So, and PCA is also fast computation, but TSNE does take time in certain case if based on our data. Fine. I guess things are clear now,
Yes, ma'am.
guys. Everyone,
Yes, ma'am.
everyone
Yes, ma'am.
understood everything.
Yes, ma'am.
Yes,
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 ma'am.
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 Yes, ma'am. Yes, ma'am.
Okay. Okay. Great.
Yeah, ma'am.
Oh, great. Great. So accordingly, by today night, you will be getting the project for this week. So accordingly, work with it, and we'll see you on Monday in the presentation session. Okay?
Okay, ma'am.
Ma'am, it's
Yeah.
just
Okay,
like
ma'am.
the same we did today. It the project will be same based on that.
Yes, ma'am.
I guess, or maybe something different because I am not setting the project, so I don't have the access to it. But based on that itself, maybe let's see.
Okay, ma'am.
Ma'am, where to
Maybe in
submit
this
it?
week, what? Sorry?
Where to submit the project?
So all this week you aren't there, or what? Where you have submitted week one, week two, week three project.
Ma'am, in the
Why
form.
you ask? Right. For the same year, also you have to do in the same format. So why you ask such
Okay, ma'am.
unnecessary questions? That is baseless. Like for week one, week two, week three, you already did it. Why you are asking where to submit? You people already know the drill. So why to continuously ask the same thing? Yeah. So I was saying maybe on the same topic, the project might be there, or maybe something different because you need to try and analyze the stuff. So maybe like that. Okay.
Yes, ma'am.
Clear,
Ma'am,
guys? Understood?
what will be the
Yes, ma'am.
expectations from you to
Oh,
present this fourth week project? Means what all the points we need to mention?
Okay. If you suppose maybe if you want, suppose if it is a unsupervised learning project is given, then I'll try. Like I want you to go ahead from the very basic that you have already done. Like the insights needs to be there. Like for that you need to do the EDA. Don't miss out the EDA since it is a model based. Don't miss out the EDA from the initial stage, the data viewing, data understanding, all of this step try and follow, then try and follow this EDA format very well because EDA you need to understand the relationship between the features. Okay, so
Okay, ma'am.
try and go ahead with the EDA. Then, if possible, try to go ahead with this hypothesis testing if possible. If not, okay, leave it. Then try to go ahead with the data, like the model selection, model training, and evaluation, and try to evaluate all of it. Or if it is a wholesome project also, try to use in any of the data set. Suppose you are working with iris, suppose I am saying suppose, try to use the supervised learning also and unsupervised learning also, and try to give it based on any of the parameter on what we can check, if it is like this, or based on that try and work fine, because I don't know how what project will be given, so try and work accordingly. So if it is a unsupervised learning, try to use one to three models, or if possible, five models at a time, and try to get the accuracy, like try to get them like evaluation matrix in a form that you get through and evaluate the details up. Fine, clear?
Yes, ma'am, it's clear.
yeah, ma'am.
Yes,
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 ma'am.
Okay,
ma'am.
fine. So for supervised, unsupervised, or any of the model you are going ahead, try to use at least three models. Fine.
Okay, ma'am. Okay, ma'am. Thank you.
Yeah. Okay,
Okay,
fine.
ma'am.
Bye.
Bye, ma'am. Thank you,
Thank you,
ma'am.
ma'am,
Ma'am.
for
Bye,
great
guys. Bye bye.
Bye,
Bye, bye.
ma'am.
explanation. Bye,
Thank you,
ma'am.
ma'am.
Bye
Bye,
bye.
ma'am.
Thank you, ma'am.
Yeah. Bye bye. Bye bye. Bye bye. Bye bye. Guys, you can leave. The session is over.